Let's see another interesting problem from leetcode. It's a medium level problem and it's saying sort colors. So each number is a different color. So actually it has to be sorted. Like first there are just three numbers 0, 1, 2. So 0 represents red, and then 1 white and 2 blue. So if you see this, the number here and the output, this is just sorting. So the 0 0 comes first, 1 1 and 2 2, and 2 0 1, it's a 0 1 2. So it's a so we can say that, okay, we can take this array and we can use sort function, and then it can be easily sorted. But if you go through the description, it's saying given an array nums with n objects, color red, white or blue, sort them in place so that objects of the same colors are adjacent, which the colors in the order red, white and blue. We'll use the integers 0 1 to represent the red color respectively. You must solve this problem without using a library sort function. So we are not allowed to use library. Okay, that's fine. Then in that case we can use merge sort or quick sort. So if you use without library, and if you use this kind of sorts, then it can be n log n. So there can be another approach. We can count this 0 0 here. So if you just traverse once and then introduce three variables. So it's a 0 variable, and count that 0. So there are 2, 1 is also 2, and in third variable 2, that's a 2. And then later, so we traverse once, and then later we can add three different loop, and then in the nums, like from the beginning, we can replace, okay, first 2 with 2 0, and then second 2 with a 2 1, and last 2 with a 2 2. That's a one. So we need a 3 loop, because we have the 3 variables, and in the 3 variables we stored the count of 0, another variable's count of 1, and another variables holding the count of 2. So we need the 3 loop. But anyway, in the first loop there is a 1 iteration, and in another 3 loop also it will be just n times. The looping is 3, all the 3 n times, because 0 count is a 0 0 just 2 times, second loop again 2 times, and the third loop again 2 times, so that's a 1. So we can say that is also 2n problems, 2 log n. So 1 log n for the first iteration, where we can count that 0 0 1 1 2 2, and in the second iteration we can replace this with a 0 0 1 1 and 2. We can do that. That's also feasible way. But if you want to do just in an order of n, one sort, if you want to sort this in a one sort, then we need to find some algorithm. So let's see that's also having like 2 pointer technique. Yes, we can say like 3 pointer here. So let's see how we can solve. So let's say it's 0 1 2 and 0 1 2. But this is the number, and you want to sort this. This is just example. So in that case, we can introduce 3 pointer. Like let's say I can say one is the beginning pointer, so 0, and then mid pointer 0, and end pointer 0. So what you can not end pointer is here, so 2, so that's a length. If the length is 6, then it's a 5. And the first time, we can set this beginning and mid pointer is the first. Like here, this is beginning, is also mid is also here, beginning pointer and mid pointer. and the end pointer is in this place. So now, so first we set the beginning and mid pointer here and the end pointer, and we just iterate one time, iterate this numbers one time, and when we iterate we can check the condition like mid less than equal to end. And in the first time, when we see that like when we see this value is 0, then we can have this logic like if the 0, then we can say switch beginning and mid, and then beginning plus plus and then mid plus plus. So this is the logic. When there's a 1, it counters 1, then just do not switch, just mid plus plus. And if it encounter 2, then we can switch to mid and end, and then end minus minus. So this is the simple algorithm here we can use using this 3 pointer technique, and then we can sort this. So let's see, let's dry run this and see how it's getting sorted. So first in the first case is a 0 0 and the beginning and mid pointer is here. And the first time when we iterate, we check that okay, this value is 0, then we can switch from the beginning and mid. So the begin is here, mid is here, so it will switch, and that's a 0. And now beginning will move and mid will move, so B and M comes here, beginning and mid, and this is 0 1. Okay, so when the pointer comes, when we iterate, the pointer comes to 1. So 1, in the case of 1, just mid plus plus, then mid will move. So we can say M plus plus. So M come here, and the begin is here. Okay, that's good. Now again, in iteration, it finds 2. So in case of 2, we can swap this to end. So anyway, the both are the same number, so it will be swapped, it will be same as it is. But in this case, end minus minus, the end pointer will come to this place. So here end comes. Okay, now again we are at here. So mid is here. So again we check with the mid, this is a 2, then it will go and swap with the end. So our end is here, so this number will be swapped. So 1 come here, and then 2 comes here, 2 comes here. But in this case, E will move, so end pointer will move here. Our begin is here itself. So in this case, again we'll check 1. So in case of 1, then we just will increase the pointer mid plus plus, and M will come here. So now middle and end is at the same place. Okay, so now it's a 0. If it is a 0, then in the case of 0, we switch with the begin. So begin is at 1, so 0 comes here. So 0 comes here, and 1 goes to this place, and 1 goes to this place. So now if you see, there is a sorted 0 0 1 1 2 2. Yeah, so it is a very simple algorithm here. We can utilize this, but yeah, we have to remember like we fix the pointer, begin and middle pointer in the beginning, and the end pointer at the end, and then whenever it's a 0, swap and the move the mid and beginning pointer. If the mid pointer is, if the value is 1, then just mid plus plus. If 2, then in that case swap and end minus minus. So we'll utilize this simple logic and try to sort. But anyway, there's a very most optimized way, but the other one is also good, like when you count that 0 and the count 1 and 2, and then later run the loop. So let's write the code. So I'll say okay, begin is equal to 0, mid is equal to 0, and end is equal to length of nums minus 1. And then you can have the one iteration for I is equal to 0, I less than length of nums I plus plus. Then you can check switch. You can say case where there's nums I. If nums I is equal to 0, then in that case we switch the number. So nums so yeah, so I think yes, first this logic is, we said earlier, like this logic is where mid less than equal to end. So I think we change this logic where mid less than is equal to end. Yeah, so when we switch, it's the nums beginning, no, it's a nums mid is equal to 0, then switch is a nums beginning is equal to nums beginning nums mid. So beginning value will go to the mid, so we can switch this in this way, and then mid plus plus beginning plus plus. The similar way, if case nums mid is equal to 0, then in this case just mid plus plus. And the last scenario, case nums mid is equal to 2, then swap with the mid and end. So nums mid comma nums end is equal to nums end comma nums mid, and then end minus minus. So that's all. Let's see the syntax or any other error. Okay, accepted, submit. Yeah, that's good. Yeah, it's bit 7497, so that's nice. Let's see the Java solution. That's I already tried, and I think it's a the logic is same. So it's Java. So in a Java also, beginning mid end, and then mid less than is equal to end. Nums mid is equal to 0. If its the value is 0, then swap mid plus plus beginning plus plus. Else if mid's 1, then mid plus plus. If nums mid is equal to 0, then swap mid and end, and then end minus minus. So that's all for today. Thank you.